if the function is 1 to 1, you end up with n linear equations. And good point. You end up with n linear equations. C is all zeros. So really you need to, so really what you need to do is you need to, but actually you don't want to do that. If C is if function is 1 to 1, you're going to end up with a single value of C. And now what you need to do is you need to go back and ask, is f of 0 equal to f of C? If yes, then it's clearly 2 to 1. And if no, it's 1 to 1. Because if the function is 2 to 1, you will never reach a point where you get n linearly independent y sub i's. So if you don't get n linearly independent y sub i's, you don't know whether you were just unlucky or whether the function was 1 to 1. So the safest thing to do is go back and plug in f of 0 equals f of c. That was a very good question. Other questions? Yeah.
And so it means that sort of the quantum magic from this is all contained within the oracle, right? Because everything else that we've done is will just be on the classical diagonals, but the entanglement all happens within when we call the oracle.
I think so, yeah. I mean, because what are we doing? What would the gate structure look like? So we started with plus, plus, plus. And now we compute f of x. And maybe I should put zeros here. And we get f of x. And we get, I guess this thing is x. And then we do lots of Hadamard's. And we don't do anything to this. And finally, we measure. So if we didn't have this f of x in here, well, you can think of these pluses as just being zeros with a Hadamard on them. If we didn't have this f of x, then we would be doing a Hadamard and undoing a Hadamard, and we wouldn't get anything. So the magic comes when f of x, when we take this oracle and compute f of x down here, and we haven't changed any of the bit values on this register, but we've changed changed their phase structure by the back action from here to here. And that lets us do the magic. So, I mean, the Hadamards are certainly very important in making the algorithm work. Yeah. But the entanglement that makes, I mean, you can't do quantum computation without entanglement. And all the entanglement comes from this step.